Perfect. Good. Right. Yeah. So hi. Yeah. Really, first time here. Really honoured to be here, and it's a tough task to start it up tonight. 6 speakers is a tough task, but you know, maybe it's going to get better as the night goes on, right? Tonight I am going to talk to you about IoT, and IoT. I mean, we're geeks here, right? We all know Monty Python. And you remember in Monty Python, there was that great sketch, was the organization for putting things on top of other things. And it feels like the IoT has sort of got there where we're now putting things connecting to other things. And, oops, go back one. We've got to the point where we've got the world's first smart condom. And I think John Cleese's reaction is kind of appropriate, right? It's sort of... Yes, anyways. So hopefully after the next half an hour, you will be able to not do that. Yeah, please don't. No. But who am I? First of all, let's kick this off. That's me. Currently IT consultant for Sigma. A 10-year veteran of Ericsson until they laid me off last year. 5 rounds of layoffs. I survived 4, missed the 5th. But in my private time, I have a company called 68 Labs, and I started that as an outlet for anything that I wanted to do that I couldn't do at work, and tried to make some money out of it to keep my wife a little happier because she did the books for the company. I am not British, I'm not American, and I'm definitely not a New Zealander. I'm actually Australian. I'm not sure why people think I'm from New Zealand, but it's like, not good, don't say that. Cloud beer, yes, occasional home brewer and beer lover. Standard disclaimer, this is my private work, does not represent my employer Sigma, but if all their clients, but maybe my own clients, if you want to be my client and pay me to do this, I'm happy to help you out. Come and speak to me later. I'm going to start off with some demonstrations, and then we'll do some talking, and then maybe some more demonstrations later. A few weeks ago, if you follow me on LinkedIn, I posted this one and I said I've been told I'm taking the name Cloud Beer too literally. I had intended to do a demo. It's not quite working at the moment. It's at the back there. If you see on the bar, there is a massive cables and pipes and God knows what. Basically, what is there is a keg of beer. Always good start. A flow sensor, this is a Hall effect sensor. It'll send a pulse out for roughly 2.5 mils of beer flowing through the pipe. Send it all off to a Raspberry Pi, and then we've got some dynamic widgets which are going to track how much you're actually drinking. Originally I had this connected to an RFID board. I decided to disconnect it because I figured maybe you don't want to track that to a person. If you want that, we can attach it again. There is a touch screen sitting next to it, which will display it. The touch screen is disabled, so don't get any ideas about playing around with it. Unfortunately, at the moment, the Pi that's controlling the flow meter is offline, so we'll try and get that up during the night. So that one's currently offline, but basically, you know, volume left in the keg and the volume poured. So a little demo, we'll try and get that one up and running. But the second demo that I'm about to show you is probably a little bit more fun. It's the main topic of the project. You know, this one was, said we're doing cloud beer, and I went, wow, how can I make beer and put it in the cloud? And okay, well, I can do this. Just for fun. But I have another demo for you. And so the question that I have for you is, if you were living here, does anyone know what this is? Yeah. Boots Clip-On? Do you know where it is? If I can find my mouse. You know where it is, yes?
Where is Clip-On is?
Yes?
Yeah, in the sea.
Yeah. That's pretty much about right. You know, it's the most southeastern point in Sweden. All right, so if you were stationed here as the lonely, lighthouse guy, and you thought to yourself on a Friday night, God, a pizza would be good. So you call up your local pizzeria and you order one. How long do you reckon it's going to get to you? How long do you reckon it would take? Anyone want to take a guess?
4 hours.
4 hours?
46 hours.
46 hours?
No, 4 to 6.
4 to 6 hours. Okay, I can tell you it takes 36 minutes.
And then you have to run quick.
I can tell you this because we did it. by strapping a pizza to the front of Salt Stink. In this box, we drove at 50 knots through the archipelago, and we tracked it. We logged our whole journey with the connected pizza box. This was the pizza when it went in the box. 46 degrees, nice and tasty, straight out of the oven. This is it after an hour and a half when we finally got back to base. And it still looks pretty good. I gave Salt Stink the challenge. I said, guys, I've got a pizza. You reckon you can destroy it? And they went, yep, no problems. I said, great. They strapped it to the front. They said, that's toast, gone. I said, all right. And we got back and there was 19 degrees. Was the temperature when we got to Eclipper. I haven't got a picture of it. I can tell you it was delicious. It was good. Still good. Quick look at the dashboard. I'll have a better, closer look at this. We'll look into this in a bit more detail a little bit later. But up here, this is basically the journey we took through the archipelago. So that was Saturday afternoon. And more fun than you can actually imagine, actually. You get to this point where you're strapped into this boat, doing 50 knots, doing these tight turns, and there's 5 other girls on the boat who are paying for it. They're screaming, their hands are in the air, and you're thinking, I wonder what the data looks like for that. You know, you should probably enjoy the ride. But yeah, we'll come back and look at that in a little bit more detail. So we'll get into the tech side of things, the more interesting stuff, I guess. There are a lot of IoT platforms out there. Adafruit's got one if you've played around with that one. There are a multitude of companies that will try and get you. If you follow any of them on Twitter or LinkedIn, you'll get bombarded with IoT all the time. But we'll start basically look at the biggest one of them all, which is AWS IoT. AWS has anyone worked with it apart from the connection guys? Has anyone else worked with this platform? Yeah? Okay. Has anyone worked with Amazon in general? Yeah, a little bit. Okay, so you'll recognize that when you start working with Amazon, there is a library like this that you have to wade through before you can actually get started, right? I mean, the thing is as powerful as you like, it's as flexible as you like, it's as configurable as you like, but to get something going, to blink a light, to say hello world is just, come on, help me out here. So in this particular project, and what I'm focusing on now is actually the Telenor Connection platform, which is actually built on top of AWS IoT, but it aggregates all of that good stuff out and brings it to you in a really simplified way, okay? You don't have to start wading through the documentation. You don't have to, everything's really there for you. You can provision your devices, you can get them up and running and get your data up online really quickly. And again, you know, I'm neurologically linked to LinkedIn. I had a device up and running inside an hour, proof of concept, which for me was quite an amazing feat. So that's what we're going to focus on for the rest of the preso. So we'll jump into the deep end, and we'll have a look at the hardware. I pitched this idea to Telenor Connection one day. It came to me at about 1 o'clock in the morning, and I thought, oh God, that's cool. I got to do that. And I wanted to call them up at the time and say, can we do this? And I realized it was 1 o'clock, and I thought maybe I need to wait till the morning. But basically, it's stock standard boxes. Pizza goes on the bottom. Coming through somewhere about there. There it is. Temperature sensor. So that gets in nice and close contact with your pizza. Then inside, stock standard 4G router, off the shelf. Nothing special, battery powered. Big battery, Raspberry Pi. All right. That's the heart of it. Middle layer there is just an easy connect shield. This is getting down into the temperature sensor. I went with this one, if you're wondering, rather than solder, because I didn't want to have solder near food. I wanted to keep the screw terminals. I thought maybe. Top layer is the Sense Hat from Raspberry Pi itself, which is a really great board. It's got the LED matrix, accelerometers, temperature sensors, barometric pressure, gyroscopes, compass, the works. So you've got basically everything I wanted in one board. Then strapped to the top, it's a lovely little USB global sat GPS. Perfectly works well in Linux, so a good choice. Total cost of parts in here about 2,000 crowns. I walked into Quodec and asked them for some pizza boxes, and they had no idea what I was going to do with it. Little did they know. So nice and simple, nothing terribly difficult. Everything that I'm going to show you tonight is not rocket science, and anybody can do it. On the software side, we're running a standard Raspbian OS. Again, nothing special. The data logger itself is written in Python. The libraries for the sensor, the library for the temperature sensor, the GPS, that's all stock standard. There is nothing that I've had to write myself. So basically, literally duct taped components together. The sensors are logging to a USB drive down here as quickly as we possibly can. Roughly works out about 1.2 times a second we write down to the USB drive. But so we don't overload the back end, we have a data uploader, the Cloud Connect aggregator, if you want to call it. It's uploading via Node.js. It's built on top of Node.js. And it's uploading every 2 seconds to get the data points. But having that means we can go back and log it again later. The Node.js uploader, the aggregator, is built on top of the AWS SDK. Okay, so already you've aggregated out all that good stuff from AWS that you've got into your user space. That's really well documented. In Stack Overflow, there's plenty of examples. Again, you'll get up and running as quickly as you like. And then all this data is going up into Amazon and then eventually comes into the Cloud Connect dashboard for later analysis. So most of the time, the most popular protocol that we'll find in the IoT world is MQTT. And surprisingly for things of this era, MQTT is quite old. It goes back to around about 1999. But it's found a really good home in IoT because it's really tolerant of bad networks, of slow latent networks, and low bandwidth networks, unreliable networks, which is typically what you'll find in IoT devices. It works on a publish-subscribe model, so clients publish their status up to a broker, and then clients also subscribe to the broker on whatever topic that they're interested in listening to. So for instance, you can have your client publish the update of what it's doing, and then any other client can subscribe to that update and get the feedback from it. At the same time, you can also publish a desired state to the topic. You can say, I want this LED to be green instead of blue, and you make that your published state. Okay, so that's a really good way. You know, your Philips Hue system, how you can control your lights through the publish and subscribe system. But being that you request a change, you don't automatically get the change instantaneously. You get it on a best effort. So the AWS IoT SDK leverages MQTT.js underneath. So again, we're bringing in all these other components for the implementation, and that really, the AWS SDK really abstracts out the difficulty of getting connected. If you can code JavaScript, and if you can know a little bit of JSON, you can use AWS SDK really quickly. You don't really even have to understand MQTT to get up and running. Before this, I had not written any MQTT at all. So you really don't have a really low barrier of entry to get in there, and you really get some rapid understanding. And again, there we go. 2 weeks ago, just a few hours, right? You know, I did electrical engineering in college, and you know, that was 10 years ago. And if you got a light to blink, that was a win, all right? And that might be a couple of days of reading data sheets. We're at a stage now where it's not that difficult. So as I said, we got all the data coming back up It's coming into the AWS platform, but that's not where we're going to actually access it. We're going to pull it in from the Cloud Connect system. Cloud Connect has a lot more going on around than what I'm just showing you tonight. I'm showing you a very simplified look at it. But Cloud Connect allows you to really simply build a dashboard. And if you've ever built a dashboard for displaying data, that's a really laborious task of actually getting your data and displaying it in some usable format that everybody can easily understand. Building widgets, finding your graph libraries, and all that stuff. That's already really in there for you from Cloud Connect. If you send up the state of a sensor, and you say temperature is 18 degrees, you jump into your Cloud Connect dashboard, there it is waiting for you. You just assign it to display it in whatever format you like. There are a lot of other widgets, so we can display things in graphs, in just plain values. If I send it a latitude and longitude, then Cloud Connect automatically knows that I want to display that as a graph. Again, and I don't have to actually do anything. The method of creating new items or new things inside Cloud Connect is a simple matter. You create a batch job. You say, I want to create 5 devices. You get 5 devices created, the security certificates for you, download them, put them onto your device, done. Okay. If I wanted to do that in AWS, it's a lot more laborious process to actually go through the process of getting that stuff set up. So you automatically get security into your things. I've shown here another couple of widgets that you've got inside the dashboard. These are some time charts that you can, analyze your data back in time. But this is a really fun one. This allows you to write a widget in Markdown. So you can actually do some if-else logic. And I can say, okay, well, I know that my last timestamp on my pizza delivery was less than 5 minutes ago and pizza is on the way. This is probably not a good one. If my orientation sensor says that the pizza's upside down, I'm probably not going to keep that one, right? A low temperature. So we can create a pizza health status here, right? I mean, we can look at all our sensors, aggregate the data from a consumer perspective, take that massive amount of sensor data and give it to you in a really simple, easy to use, easily digestible format with a very low effort. So, having said that, let's have a look at a bit of a demo. Hopefully this will work. There it is. So, apparently at that time I was doing 0.73 meters per second. We still have power, but we're not catching anything. Let me go down. There we go. Okay. So we actually do have a GPS lock here, so we know where, there we go, 2.4 meters per second. The acceleration in the Z direction is always fun. 1.71, We, on Salt Stink, we managed to get that up to 8. But I don't know, can you catch? See if I can throw it to you. That wasn't that bad. But we can scroll down and have a look at some of the other sensors that we're pulling in. So we've got pitch sensors, so you can spin it around a few times. We've got pitch, orientation, throw it upside down. There you go. 2 ambient temperature sensors. Unfortunately, these are really badly placed. They're right above the CPU of the Pi, so they're constantly... they're about 10 degrees out. Not a good placement, but there you go. The altitude, I'm not trusting the GPS location data here, incidentally. If we're minus 23 meters, okay, but yeah. So this is what we threw at it. Always a bit of fun. But yep, go back to the presentation. Throw it back if you like, pass it around. I don't mind. It's done its job now. So where are we at? Okay. So now that we've got all this data, we've got to do something with it. So remember I said that we're built on top of AWS IoT. So we have all the good stuff that AWS lets you do. Lambda functions. We let you get into the data with Elasticsearch and all the other big data utilities that you want. Cloud Connect will give you data processing utilities. Don't worry about that. But if you want to get into the data yourself, go for it. Pull that data out, put it into your app, put it into your own dashboards, integrate it into your websites. Everything's available through REST APIs, which again makes it easy to integrate that into your iOS apps, right? I mean, for instance, the original concept that I had for this was, you pick up your phone, you order your pizza, right? Okay, then you see in the app, okay, order received, order in the oven, order prepared, it's shipping out, then we'll get all the data. It used to be quite popular in Australia that you'd name your pizzeria after fast Italian cars. You'd have the Ferrari, pizzeria or whatever. Well, if you're going to deliver my, pizza in a Ferrari, this is like a little marketing gimmick, right? It's ridiculous, okay? I'm not expecting to see this in a pizza box anytime soon. My intention was to prove the point, prove the concept, and more so to throw this at SaltStink and consumer level hardware that you can buy at Shell & Company will survive that. Okay? 10 years ago, that wasn't possible, at that price point. For what it's worth, the Raspberry Pi Sense Hat that's sitting on top was actually developed to go into space. So they sent that up to the space station for some experimentation. To wrap it up, and then we can get into some Q&A if you like. What's next is for me to make some improvements. But when I started the project, there is a bloke in New York called Scott Wiener who runs a company called Scott's Pizza Tours. And he does tours in New York of old pizzerias from 1890, 1900, coal-fired, wood-fired, that kind of stuff. He does them on a big school bus. He also happens to have written a book on pizza boxes, and he has the world record for the world's largest pizza box collection. That box is going to him next week, hopefully. And he's going to take it out for a spin, and then we'll come back and we'll see where we get with that, right? So I dropped him an email, and I was like, mate, I've done this box that does sensing. He's like, whoa, cool! I'm like, okay, you're a little 2-inch pizza boxes, but hey, that's good. That's good. So, that's what's next. So hopefully, this is not the future. Hopefully it's more in line of this sort of work. But hopefully I've given you enough to think about it. If you are interested in IoT, if you are interested in developing this, I cannot recommend this hardware platform enough. The Raspberry Pi and Cloud Connect, AWS IoT. It's a really quick, really efficient, really simple way of proving a concept. If you're a BTH and you're a student, if I was a student at BTH and I could get my hands on one of those, that would be the ideal platform. It's really flexible. It's really simple. There's a few people to thank. Everyone on that board there helped me out in some way. Paying for hardware, paying for technical assistance, taking SaltStink out to Eclipon. They confirmed that to me on Wednesday last week, and I was getting kind of nervous. My original plan was to actually do the SaltStink run now during the presentation and actually have the data up on the screen. Given that some of the demos haven't quite gone to plan now, I'm kind of glad we did that on Saturday night instead. That's all from me on this side. I've really only skimmed the surface of what's in there, of what I've done and what I've worked on. It's all documented. So if you want to know more, if you want to get involved or you want to try something else, come and grab me during the night, grab me on social media later. Or come and ask me a question and I'll document as much as I can and put it out online. The code will be up in GitHub, so it'll all be available if you want to try something out yourself. That's all I have for tonight. Thank you.